We were looking at how can we find the probabilities for a standard normal random variable using the z-table. We discussed how to find probabilities to the left of the z-value, to the right of the z-value, and then probabilities between two z-values. Here, we looked at the first case where both z-values were positive. Then we looked at where one z-value is positive, one is negative. Now we want to look at where both z-values are negative, right? So that's the third last case we want to consider here. So let's say we want to find probability z is greater than minus 1.7 less than minus 1. Let's first plot it and see how this looks like. So this is essentially, so here this is 0. This is minus 1.7. This is. So we're interested in this probability z is less than minus 1 minus probability z is less than minus 1.7, which is this area, right? Because see, if you look at this, this is the probability z is less than minus 1, right? And from this, what we do is we just remove this probability. Z is less than minus 1.7. So the remaining that is left is just this, right? Z is between minus 1 and minus 1.7, right? So this is what's left. Let's just erase this and let's just make it again. Sorry. Right, so this is 0, this is minus 1.7, this is 1. So we know this area represents the probability z is greater than minus 1.7, less than minus 1. So I can write this probability as z is less than minus 1 minus probability z is less than minus 1.7. So now we said whenever we want to find probabilities for a standard normal random variable using the z-table that we're using, the z-table that we're using has CDF values only for positive values. So it gives us probabilities in the form probability capital Z less than equal to small z for z greater than 0, right? Right, so the z-table that we have has probabilities in this form for positive values of small z. So if we have any negative values of z, the first step is to ensure we only have positive values of z using symmetry property. And once we have positive values of z, then we ensure then the CDF form. Right, so if we go back to what we're finding, so over here, we can see we have negative values of z, right? Right, so whenever we're finding probabilities for standard normal random variable, so if we have negative values of z, so first off, we use the symmetry property. So we know the idea here is the z-table does not have CDF values for negative values of z. So use symmetry property. Of normal distribution. Right, and the symmetry property is a standard normal random variable, any normal random variable is symmetric around its mean. So a standard normal random variable is symmetric around z. So here what I'm going to do is, so let's apply for probability z less than minus 1. This is 0. This is minus 1. Right, so now this is probability z less than minus 1. Now by symmetry, we know this is the same as the probability z is greater than 1. Right? So this is the area that we're interested in. The area that probability z is less than minus 1. By symmetry, this is the same as probability z is greater than 1. So if I make this area here, so what I'm essentially interested in is this area. This area, which is probability z greater than 1. Similarly, over here, what we're interested in is the probability z is less than minus 1.7. So this area is probability z is less than minus 1.7. And this is the same as this area by symmetry. Right, so what we're interested in is essentially this, if we write it in terms of positive values. So we're interested in this, area probability z is greater than 1.7. So the first step is that if you have negative values of z, you write them in terms of positive values of z using symmetry. So basically, using symmetry, I can essentially write probability z less than minus 1 as probability z is greater than 1. And we can write probability z less than minus 1.7 as probability z is greater than 1.7, right? Because by symmetry, this is the same as this area. Right, so now what we're going to do is, now we have it in terms of positive values of z. But we know the z table that we're using only has CDF values, right? So this is not in terms of CDF. Once you only have positive values of small z, here we do +1 plus 1.7 rather than -1 minus 1.7. We need to make sure it's in terms of CDF of z. Now the idea is that z table only has CDF values of z. So now we write in terms of CDF of z, for which we use complement. In terms of CDF z, which can be read from z table then. Right, so now we can write this probability z greater than 1 as using the complement rule as 1 minus probability z less than 1 minus probability z greater than 1.7 using complement rule can be written as 1 minus probability z less than 1.7. Right, now if we just simplify this a bit, so it just becomes, if you open the brackets, 1 minus probability z less than 1 minus 1 plus probability z less than 1.7. Now this is in the form of CDF for positive value z. We have +1 here. This is in terms of CDF for positive values. We can write this as 1 minus 5. Oh, sorry, this 1 minus 1 gets cancelled. So this becomes +5, 1.7. Right? Because for a standard normal random variable, we represent the CDF using phi rather than using z. And now you can read these from z table, because both of them are in the form of CDF of positive values. So if we go back to the z table, so let's read for both 1 and 1.7. So if I first read for 1, so this is a z value here up to the first decimal place 1.0, the second decimal place is 0. So this probability is 0.8413. So this is just 0.8413 plus pi 1.7. So if you go back to the z table, so 1.7 you already read. This is the z value correct to the first decimal place. And then the second decimal place which is 0. So it's 0.955. So this just, sorry. Okay, so then this just becomes, okay, sorry, so my bad, this was minus 5, sorry. So this was minus 0.8413 plus, this just becomes 0.9554, which is just equal to 0.1141, right? So let me just clear this. Okay. So the idea is this, that whenever you're finding probabilities for standard normal random variable using the z table, first ensure you only have positive values of z here. If there are any negative values, use symmetry property. And once you only have positive values of z, if any probability is not in the form of CDF, just rewrite it in terms of CDF. Because then once you have probabilities in the form of CDF for positive values of z, you can just read them from the z table.